Nuclear propulsion includes a wide variety of propulsion methods that use some form of nuclear reaction as their primary power source. Nuclear propulsion could help get humans to Mars faster. Two types of methods are being studied: nuclear electric propulsion and nuclear thermal propulsion. Nuclear-powered rockets are more energy-dense than chemical rockets and twice as efficient. This is because lighter gases are easier to accelerate. To understand this in more depth, we have to understand a term specific impulse. It is the measure of how efficiently a reaction mass engine creates thrust. For engine whose reaction mass is only the fuel they carry, SI is exactly proportional to exhaust gas velocity. A proportional system with higher SI uses the mass of the propellant more efficiently. In the case of a rocket, this means less propellant needed for a given delta V. The higher we can push the specific impulse, the less fuel we need. Engine uses electric power to propel ions. Xenon atom is released into an ionization chamber and then bombarded with high-energy electrons. Collision provides positive xenon ion and more electrons. These electrons are collected by the positively charged chambered walls, while xenon ion is accelerated out of the chamber exit with a speed up to 40 km per second. Exhaust velocity of NEP equals 40 km per second. In comparison to chemical rocket equals 3.5 km per second. NEP provides the best SI. It can provide enough thrust in a short span of time, which is necessary for some very important maneuver. To increase thrust, mass flow rate needs to be increased, and for that more electricity would be needed. And to provide that, the scale of solar panels would be highly impractical. It works by harnessing heat created during nuclear fission to provide the energy needed to expand and accelerate propellant through an exhaust nozzle. In nuclear reactor, what happens is basic. A chain reaction of neutron colliding with uranium atoms splits them, creating more neutron and massive amount of heat. To capture the heat, typically liquid hydrogen is pushed through the reactor core, which cools the reactor and passes heat to hydrogen, which quickly expands and accelerates out of the thrust nozzle. System offers a greater flexibility for deep space missions. They can reduce travel time to Mars by up to 25%. They can also enable broader launch windows that are not dependent on orbital alignments and allow astronauts to abort mission and return to Earth if necessary.